Now that we've started nuclear physics, our work will revolve around the atom. So we need to make sure that we all are in the same page in regards to what the atom actually is. So we need to define what our key components of it actually are. So inside of our nucleus, this part here, we have two components. These are our protons and our neutrons. Around the nucleus, we also have electrons. A proton has a positive charge. An electron has a negative charge. And a neutron has no charge. Atoms are one of the smallest things that we know of. The whole diameter of the atom is only 10 to the minus 8 centimeters, which is really small. However, the nucleus itself, this part in here, the middle part, that is between 10 to the minus 12 to 10 to the minus 13 centimeters. Because atoms are so small, we don't use the regular kilos or grams with it. We use what's called an AMU, which stands for atomic mass unit. Where one atomic mass unit is equal to 1.6606 times 10 to the negative 27 kilograms, which is very, very small and very, very light. But that's talking about all the different components in there. So a neutron has a weight of 1.008665 AMU. I'm writing it here as just U, just for simplicity's sake. A proton has a mass of 1.007277 U. An electron has a mass even lighter than that of the proton and the neutron at 0.005486 atomic mass units. These masses are extremely useful, and we should make sure that we've copied that down and we are prepared to use them in the future. A couple of other points to make note of. Our atomic mass that's the number of protons and neutrons. We don't call it our... These are some really key points when working with nuclear physics. We change and look at our mass of our atoms. So those numbers are going to be extremely useful. Two other things that we should be aware of is our atomic mass, which we denote with an A, and that is the number of protons and neutrons. We do not include the electrons, as you can see, their weight is much, much less than that of the protons and the neutrons. The other thing we need to be aware of is the atomic number. And that's just the number of protons. Now we're going to have a look at how we write the atom. So, when we have this, we write an atom with its chemical element. So when we're dealing with carbon, which has a chemical element of C, we write the number of protons, the atomic number, as a superscript. So carbon has 6 protons. It also has 6 neutrons. so its atomic mass will be 12. However, this can appear differently. It will be the same thing as writing it on the other side or on either side. So putting the 6 up here and then the 12 down there. Well, you can also write it as a straight line where the carbon, and then you'll have the atomic number and the atomic mass. Sometimes you'll find it with just the number at the top or the number at the bottom, and that will mean that you have to calculate the other one, or it's an assumed knowledge that you should be able to determine what the number of protons or the mass is of that element. So now that we've gone through some of our definitions, let's do a little question to get our brains working again. This question is, if an atom was the size of an apple, how big would that apple then be? So would the apple be the size of the moon, the Earth, Mars, or a blue whale? Let's see. So when we're calculating this, we're going to be looking at the atomic diameter and an apple diameter. Well, they're both in centimeters, so we don't have to worry about the unit change. But all our answers, apart from the blue whale, are in kilometers. So we're going to need to do some unit conversion.